All right, you guys. Last time we looked at angle relationships in circles. This time we're going to switch the conversation, look at segment relationships. Now, if you look, these four situations, they look almost exactly like what we talked about last time, mainly because they are. Except instead of talking about the angle and degree relationships going on in each of these situations, there's some relationships going on with the segment values as well. So just like when we had intersecting chords, there's a relationship here that has to do with these segments as well. So the relationship is if we take part of one of the chords times the other part, so that would be we took IM and we multiplied it by MJ, that would have to equal the same operation on the other chord. So it's a proportional idea. LM times MK. So this is a formula that you will find on your formula sheet that can be found in Schoology in the Unit 10 folder. There's a formula for this. You don't need to memorize it. You need to know how to apply it. So let's look at a quick little problem. If I knew that we had X here, and we had 4 here, and we had 8, and maybe we had 2, you would just want to take those values and plug into the formula. Well, IM is X. If we multiply that times MJ, which is 4, that has to equal LM, which is 2, times 8. Produces an algebraic equation. All we need to do is be able to solve this. X times 4 is 4x. 2 times 8 is 16. If we divide both sides by 4, we find out x is 4. We can plug back in if we needed to, if we were asked a different equation, or a different question. Just realize how you plug in and then go after the solution method. Okay? Now, this problem, we have two secants. This is it's more difficult. There's some chances for small mistakes here, so please be careful. Let me show you the formula first. Okay, let's see if I can get that off of there. And here we go with the formula. Now, here's how I have it memorized in my head. There's a part of each secant that is outside of the circle. Well, if we take the outside portion of one secant, and we multiply times the entire secant, the entire measure from Q all the way to R. Well, that has to equal the same situation from the other secant. The outside portion, RU, times the entire secant from S to R. That's our formula. But let me show you how this can cause some trouble. All right, let's make up some simple measurements. Let's say I had 6 here. I have Y here. Let's say that's 7, and this is 8. Just making these numbers up, probably not going to work out great, but let's just see how we plug into the formula. Simple, RT, that's 6. So here I would plug in 6. I'm going to multiply it times QR. Now be careful, QR is not 8. QR is 8 plus 6, which is 14. There's where people make a mistake. Let's try and see if we can do better on the other side. All right, we have Y. Well, let me actually switch this. This is going to make a quadratic equation. Let's switch these just to create a little bit easier problem. Should have thought ahead, but that's fine. 7 is the outside portion of the secant times, now be careful, the entire secant is not Y, it's not 7. It's the 2 added up like we did on the other side. Y plus 7. So in order to solve this, the left side, not so bad. 6 times 14 is 84. On the right side, be careful. We got to distribute that 7. We get 7y plus 49. Now, again, I got a basic algebra problem. If I subtract by 49 on both sides, 84 minus 49 is 35. Ooh, look, this worked out pretty. And then, because that canceled out the 49, divide both sides by 7. I got pretty lucky here. This is pretty. y is 5. Okay? Again, plug back in if you need to. Okay? This situation, not too different. If we take, so here we have a secant and a tangent. All right? So the secant is handled in the exact same way. If I take the outside portion of the secant, which is NP, times the entire secant, which is from N to O, that has to equal the tangent times itself. Fn squared. Okay? So again, we got the formula. We can give it a quick try. If I call the tangent z, maybe the outside portion here is 2. And I'll make this work out nice and pretty. NP is 2 times NO. Again, 2 plus 6 is 8. I'm going to set that equal to the tangent squared. 16 equals z squared. In order to get rid of a square, the opposite operation is a square root. If I square root both sides, I would technically get a positive or a negative 4, but this is geometry, so we're looking at only positive values. Just try and remember, 4 times 4 is 16, but so is negative 4 times negative 4. Okay? Now this last one, way easier. Anytime we have a point in space, the distance to one horizon has got to equal the distance to the other horizon. These are two tangents. VW will always equal WX. The only thing I can see here is I give you a problem like 2 times n plus 10 equals 5n minus 11. You should set those equal. Subtract 2n on both sides. I only got 10 on the left side now, and I got 3n minus 11. If I add 11 to both sides, now I got 21 equals 3n. If I divide both sides by 3, I got n. Come on. N is 7. Okay, this is examples of these segment relationships that exist in circles. The formulas will be there for you. You need to be prepared to grab the correct formula, plug the values in correctly, and believe it or not, we would like you to be able to handle the algebra too. We know you can do it. You've been doing it all year. I'll see you in class.